This is section 12.2, arithmetic, arithmetic sequences and series. Now, we've just kind of seen some general sequences and a little bit about series thus far. There are certain types of sequences and series that are very nice to work with because they are very well behaved, and they're formulas that we can do some of the things that we've been trying to do kind of the hard way by finding patterns. These are actually a whole lot easier. So, for example, if I wrote this sequence, 8, 4, 0, -4, -8, etc. What's the pattern you see here? Well, I'm hoping you're thinking that the pattern is to subtract 4 each time. Every time I'm just subtracting 4 to get the next thing. This is that recursive idea that we talked about. And that sequence, like this one, is one that has a recursive pattern that involves addition. Keep in mind that addition of a negative number ends up being subtraction. So in this one over here, this is +2 each time. And over here, I want to go back and amend that. That's plus -4 and plus -4. It's a small little change I'm making, but I do want to define this in terms of addition. Any sequence that follows this kind of pattern where you're adding a constant, and it's the same constant you add to get every next term. Okay, so this type of sequence is called an arithmetic sequence. Funny word in the English language. If it's an adjective describing what kind of sequence it is, it's called arithmetic with the emphasis on me. But if it's an operation or a set of operations you do, we call that arithmetic with emphasis on the rith. It's kind of interesting. So it's pronounced differently depending on how it's being used. Anyway, so an arithmetic sequence, as you can read in the notes, is obtained by adding a fixed number to the previous term, and that's going to be an arithmetic sequence. That number that we're adding has a name. It's called the common difference. So the common difference here, D, is -4. And the common difference here, D, is 2. It's called the common difference because if you took any element in the sequence and the one right before it, and first started with the one that you picked first, like 11, and if you were to subtract the one before it, the difference will always be 2 for any pair I picked. So, for example, if I picked these two here, -8, the latter one, the one's further out, minus the one right before it, so -8 plus 4 is -4. That's our common difference. Okay. Then I give you another example. 5, 9, 13, 17, 21 is arithmetic, and its common difference, D, would be 4. I believe that you can see that in your notes. All right. So if you're given an arithmetic sequence, let me copy this one down. So we have a sequence, and we're asked to find the common difference. You can pick anything in there, well, except for the first one. I should probably have said that earlier. You can't pick the first one, but pick any of them except for the first one and subtract from it the one right before it. So I'm going to pick -5 minus -7, which is the same thing as -5 plus 7, which is 2. Okay. and again, it doesn't matter which pair we pick, we would have got the same result. Let's say, for example, I had chosen -1 and -3. The common difference should be -1 minus the one right before it, -3. And -1 minus -3 is the same thing as -1 plus 3, which of course is 2. So any pair of these that you pick and take the one behind minus the one before it will give you a common difference for that sequence. Okay. Now, one of the tasks that you'll be asked to do for our next example is to write the first 5 terms of an arithmetic sequence and look for a pattern for arithmetic sequences. So, they tell us that the first term is 7, and a good way to write that is a sub 1 is 7. I'm just copying down what they're telling me. And the common difference is -3, so D is -3. Okay, so if we start with 7 as the first term, add -3 to that, you should get 4. Add -3 to that answer, you should get 1, plus -3, -2, plus -3, -5. See, that's the first 5 terms of the sequence. That's what we were asked to find. And so that's an answer for that. So, of course, the pattern is played out that you're always adding the same number to get the next term for any given sequence. All right. So the next example, write the first 5 terms. I guess that was problem A. I'll call this problem B. The first term is -12. And they say the common difference is 5. And again, they want the first 5 terms. So -12 is the first one. Plus 5 is -7. Plus 5 is -2. Plus 5 is 3. Plus 5 is 8. And there you have them. Okay. Now, what I'd like to do with this idea is go back to, I guess it doesn't matter which one we pick. Let me see which one I want to use as an example. It doesn't really matter. Okay. Let's pick the one that's 5, 7, 9, 11, 13. And I want to talk about how those occur. So a sub 1 is 5. And to get to a sub 2, we would add 2. This is the example from up above to get our new answer. And then we're going to take that last answer and add another 2 to it. You notice I'm not simplifying. To get the fourth term, I'm going to add the third term plus yet another 2. And the fifth one I get by taking the last answer. How many 2's does that last answer have? 3 of them. Plus the new 2 to get the next one. And my question here is, and this would be true for any of them, if I picked a different one to look at, this same process would have worked. Is there a way to find a formula for the nth term of this sequence? Well, let's go back to the fifth one for a minute. Notice that all of them have this in common, that it's 5 plus some number of 2's. And to have repeated addition, remember that repeated addition is done faster with multiplication. So how many 2's are there here? Well, there are 4 of them, right? And for the one before, that's 5 plus how many? 3 2's, right. And the next one above that is 5 plus how many? 2 times 2. And the one above that, 5 plus 1 times 2. And if you look at the pattern going backwards, it seems pretty obvious. What we're doing here, we're taking 5 plus, the next number down would be 0 times 2. And let's double check it. Is 5 plus 0 5? Yep, that works. And so what we're wanting to do for this a sub n one is we're going to have 5 plus some number of 2's that are added together. And the question is, how many of them are there? Well, to get that answer, you might take a look at the number of the subscript. Let's say a sub 5, we added 4 2's. But for a sub 4, we added 3 2's. So what's the relationship between the subscript n and the number of 2's we add? Well, there are one fewer 2's than that subscript. So if that subscript is n, this should be n minus 1. So that when the subscript is 3, for example, we should be adding 2 2's, which is what actually happens. So it'll be 5 plus n minus 1 times 2. So that's for that specific arithmetic sequence. As it turns out, we can use that to build a formula for the nth term of an arithmetic sequence. Using that process that we did over there to the right as a model. We could say that the nth term a sub n will always be, well, in that example it was 5. Well, what was 5 in the original information? Well, it was the first term. So you'll always have the first term here plus n minus 1. It'll always be n minus 1 times what? Where did the 2 come from? Right, that's our common difference. And so this is the formula for the nth term of an arithmetic sequence. So no longer would you have to sort of guess and check and try again and all that kind of stuff. If you can figure out that it's arithmetic, then this formula gives you the nth term formula that you would need to have. But instead of guessing and checking, you can just come up with it. All right, so let's look at the next example. We're supposed to find a sub 13. And they tell us it's arithmetic. And we're supposed to find a sub n for this arithmetic sequence. And they give us the beginning of it. It's -3, comma 1, comma 5, comma 9, comma dot, dot, dot. So what you're looking for, since they told us it's arithmetic, is what is the addition pattern to get from any term to the next one? What are we adding? Well, you're right, it's 4. So what this information gives me directly is that the first term is -3, and we just calculated the common difference d, which is 4. So that means that a sub n is a sub 1 that we just found plus n minus 1 times d, which in this problem is 4. So to find a sub 13, that means that for that problem, 13 will be the value of n. And then you do the arithmetic and get the answer of 45. Now, I'm actually okay. Excuse me. I'm actually okay with your leaving a sub n in this form. You may see people do the distribution and combining of like terms that I'm about to do, but let me tell you, this form right here is fine with me. But you may see this done, so I wanted to have you see it. If you distribute the 4 and then combine like terms, you'll get 4n minus 7. And like I said, I generally don't do that. I don't think it's worth the extra effort. But if you do, it's not wrong. But I do accept the undistributed version. Okay, let's do another example. This one says find a sub 18 and a sub n for the arithmetic sequence. Let me write that down. We want a sub n. Do you notice I found that first? I'm not sure why they give the directions to find a sub 18 before finding a sub n, but that's all right. We're supposed to find those two. If we're told that it's arithmetic and that a sub 2 is 9 and a sub 3 is 15. Well, because those are adjacent to each other in the sequence, you can think, well, what would I add to a sub 2 to get to a sub 3? And that should be my common difference. So that means that the common difference is 6. And because the second one is given, you can actually reverse and go backwards to the first term. So the first term is going to be start at 9, and instead of adding 6, which would take us to 15, what would we do to go backwards? Right, we'd subtract 6. And so the first term is 3. So that means that a sub n is a sub 1, which is 3, plus n minus 1 times d, which was 6. And there's our a sub n. And then a sub 18 is 3 plus 18 minus 1 multiplied by 6. And then you do the arithmetic. And you should get 105 when you're done. 105. Okay. So, the next example. Suppose an arithmetic sequence has a sub 8 equal to negative 16. Uh-oh, that's not that close to the beginning. Not like the a sub 2 we had last time. And a sub 16 is negative 40. And we're asked to find a sub 1. Okay, that's our task. So, unfortunately, a sub 8 and a sub 16 are not adjacent terms. So, and this is going to happen with a lot of these problems, is that the information they give you is not enough by itself. Like we did on the last one, we could kind of eke out what d was easily and what a sub 1 was easily. What we're going to have to do in this case is take our formula for all arithmetic sequences. We were told this one was arithmetic, so it will work. And we're going to substitute in the two pieces of information we were given. So the first one was the a sub n, the nth term, a sub 8. The answer is negative 16. That's our a sub n value for n equals 8. Is going to be unknown a sub 1 plus n, which gave me negative 16. That was 8 because it's the 8th term. 8 minus 1 times d. Again, unknown d. So I can't fill that in. Then I'm going to do the same thing with the other piece of information I was given. Negative 40 is one of my terms. And I'll get negative 40 by taking the unknown first term plus n, which for negative 40 they told me that was 16, minus 1 times unknown d. And that has created a system of equations. And so what I'm going to do is I'm going to simplify them each a little bit. That'll become a sub 1 plus 7d equals negative 16. And the other one will become a sub 1 plus 15d equals negative 40. So what we need to do is solve this system of two equations with two unknowns. What we might do, because a sub 1 is the same for both of them, is I'm going to multiply the first equation by negative 1 and add it and the second equation together and put the result down here. So negative 1 times a sub 1 is negative a sub 1 plus a sub 1 is 0 a sub 1, which I'm not going to write. Then negative 1 times positive 7d is negative 7d plus 15d is 8d equals, and then negative 1 times negative 16 is positive 16 plus negative 40 is negative 24, and then I can solve for d. So the common difference is negative 3. Then what I can do, now that I know d, I can take that answer back into either one of these equations, whichever one I like, and solve for a sub 1. So I'm going to use the first one. Doesn't really matter. So that'll be a sub 1, which I don't know yet, plus 7 times d, which we now know is negative 3, should equal negative 16. So a sub 1 minus 21 equals negative 16. Then to solve for a sub 1, adding 21 to both sides gives me 5. And of course, that's what I was asked to find. So I found it, and we're done. Okay. Excuse me. So for the next example, you've got a graph there, and we're supposed to find the formula for the nth term of the sequence that's graphed below. All right, so let me see. So when you look at that graph, those dots, they do appear to line up. So if I were to find the equation of that line, is if there were a full line there, all connected, I think I could do this. So, what's the slope? Well, looking at the first mark to the next mark, the rise amount is actually negative. We're going down 0.5, so our rise amount is negative 0.5. And our run amount is going from 1 to 2. That's a run of 1. And so our slope is negative 0.5. And if you extended that pattern up a little bit more, as if there were a line and it went all the way through all the points in both directions, it appears, and it's true, by the way, that the y-intercept that it would get you to, if you went up 0.5 and left 1, you'd be at 4. Well, they wrote 4.0. So that's your y-intercept. So that tells us that the equation of the line that passes through those points will be y equals mx plus b. And so that implies that our a sub n, not y, because this is an a sub n thing, is negative 1/2, which is what negative 0.5 is as a fraction, times n, because our independent variable in this is really n, not x, plus 4. Now, we do have only those dots plotted. and that's it. Notice at 7 there is no dot, so it actually is intended to stop. So our domain, our set of numbers we're using for n, so we start at 1 and use all the numbers up to 6, and we stop. So that's the domain. And then the range is a set of numbers we're getting for the outputs for the a sub n values that are plotted there. And so that is the set of numbers. Since it's a small set, I'm just going to list them. 3.5 and 3 and 2.5 and 2 and 1.5 and 1. That's the range. Those are all of the outputs that we get if we use all of the numbers 1 through 6. If we use the entire domain. So that's the range. Okay. Now, I should be very careful here. That's an idea of what the domain is, but please keep in mind this notation is actually deceiving right here, because if I left it at that, it would mean that any number between 1 and 6 would be okay, like 2.3. And of course, n has to be a positive integer. So I'm going to amend my statement and say, yeah, that's not bad. It gives me an idea of what they are, but they can only be positive integers. So I'm going to list them. And if there were a lot of them, I would establish a pattern, put comma, dot, 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 comma in the last one. This is a short one, so I'm not going to have to do that. But if there were like 600 numbers, I'd say 1, 2, 3, 4 with commas between them, comma, dot, 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 comma, 600, and that would do it. With a relatively small set, you can just list all of them. It's not that hard to do. All right. So now the next thing I want to find is there a formula for S sub n for arithmetic sequences? And that, remember, that's called the nth partial sum. S sub n is the nth partial sum of a series. So to find that, I think, yeah, I'm going to do this one. Let's say that we wanted to find the sum of the first 100 positive integers. Okay, so that might be written as sigma j equals 1 to 100 of j, which of course is put in 1 plus, put in 2 plus, put in 3 plus, put in 4, etc. And then getting toward the end, we'd have 96, 97, 98, 99, and 100. And that's the last one. Now, to figure out the formula that I'm developing here, I'm going to use a little bit of a trick. I'm going to ask you to look at this. What is the sum of the first term, which is 1, and the last term, which is 100? 1 plus 100 is 101. Now, if I were to ask you to add the second term to the penultimate term, that's second from the end, 2 plus 99, that's also 101. And the third one, added to the 1, 3 from the end, 3 plus 98, is also 101. So I'm going to continue to get 101s using pairs of these, selected very carefully. Since there are 100 numbers, how many pairs of numbers will we have? It's going to be 50. There are 50 pairs, right? So if there are 50 pairs that add up to 101, then the total sum, S sub 100, could be found, instead of doing repeated addition of 101 plus 101 plus 101, until I have 50 of those, is I could use repeated addition is multiplication and get that, which is 5,050. So that's one way to do that. So let's see if we can come up with a formula using that as a basis. Well, of all those pairs, which pair is the easiest one to work with? Would it be always pick the third one and the 1/3 from the end? Or always pick the second one and the 1/2 from the end? Or do you think it would be easiest to use the first one and the last one? Well, as it turns out, the first and last are really the best. So let's see if we can come up with a formula. Where did the 50 come from? Where did that come from? Well, it was 100 things that were being added together, and we were pairing them up, so the 50 came from dividing the number of things in our list to add up by 2. And so up here formulaically, that's going to be n divided by 2. So this S sub 100 we're talking about here, that's what we divided by 2 to get the 50. Now, the 101, where did that come from? Well, as I said earlier, there are several pairs we could choose, but the easiest one is going to be the first one, which would be a sub 1, and the last one, which if we're doing the sum of the first 200, the last one is the 100th term, a sub 100. So more generically, up here, we'll do a sub 1 plus a sub whatever n is. Okay, so in this problem, n is 100, so that's why this is 100, and that's why this is 100. And that takes us to that equation that we just wrote up there, which is the sum of the first n terms of an arithmetic sequence. So that's the name of this one. Sum of the first n terms of an arithmetic sequence. And that too is a formula that you should commit to memory. And the book offers an alternate version of that, which I don't use, so I'm not even going to mention it because I won't use it in any of my examples. If you decide you like it and use it, as long as you use it correctly, I have no problem with that. I'm just not going to support the use of it because I'm just going to have you memorize one thing instead of two. So we've got -9 and -5, -1 and 3 and 7. And as we're going to find, one of the first things we should do, unless they've told us it's arithmetic for sure, is that we should double check to see that we think we know what kind of sequence it is. So -9 plus what is -5? Well, that's 4. And if you look at all the rest of them, would adding 4 always give you the next answer? Well, at least through 7, yes. And of course, this one they told us was arithmetic, so that's good. We just now know that D is 4. And of course, a sub 1 for this sequence is -9. Okay, so S sub 12 is going to be n, which is 12, divided by 2, times a sub 1, which is -9, plus a sub 12. And I don't know what a sub 12 is yet. And so I'm going to also know that I've memorized the nth term of an arithmetic sequence is always a sub 1 plus n minus 1 times d. So a sub 12 is going to be the first term, which is negative 9, plus n, which is 12, minus 1 times the common difference, which is 4. And when you do that arithmetic, you end up getting, I don't want to make a mistake. Well, it's 1144 minus 9 is 35. If I got that wrong, I apologize. I think I did get it right, but yeah, I hate making mistakes like that. So what I can do now is I could actually go back and take out a sub 12 as a symbol and put in there what a sub 12 is. So let me do that. So that's 35 now. And negative 9 plus 35 is 26 times 6 is 156. Okay. Let's see. They ask us to write a formula for part B for finding any partial sum, not just specifically S sub 12. So let's see if we got that for this one. S of n should be n over 2 times a sub 1, which we now know is negative 9, plus a sub n, which is going to be, for this one, let me go up here, specifically for this one, that's going to be negative 9, plus n minus 1 times 4. So that's what our a sub n will be. And so simplifying that just a little bit inside the parentheses, that's negative 18 plus 4n minus 4. Negative 18 minus 4 is negative 22. So that becomes 4n minus 22. So there's a formula for S sub n for the sequence defined above. And then we're supposed to find the sum of the first 60 positive integers. Oh, I'm sorry. I messed up. Let me erase a whole bunch of stuff. Part B was not relating back to the other one at all. It was just a brand new problem, and I just messed up and did as if we were doing the continuation of that same sequence. Okay, so there we go. So for the sum of the first 60 positive integers, well, that's going to be 60, which is n, divided by 2. Oh, and I forgot to erase something here. Hold on. This is going to be S sub 60 specifically. Not the generic S sub n. The first of the 60 positive integers is 1, and the 60th of the first 60 positive integers is 60, and you do that arithmetic and you'll get 1,830. Very quick sum of the first 60 positive integers, because that's definitely arithmetic. All right, next example. The sum of the first 17 terms of an arithmetic sequence is 187. So the sum of the first 17 terms of an arithmetic sequence is 187. Okay? And if a sub 17 is negative 13, we're supposed to find a sub 1, and we're supposed to find d. We're going to make sure we find both of those. Okay, so using the S sub n formula, because it's arithmetic, we know that the 187 answer is arrived at by taking n, which is 17, divided by 2, times the quantity a sub 1, which I don't know, plus a sub 17, which I'm told is negative 13. Okay, so if that's true, then we should be able to solve for a sub 1. So I think first I'm going to multiply both sides of that equation by 2. So I'm getting my calculator to make sure I don't make any mistakes. So that's 374 equals 17 times a sub 1 minus 13. Then divide both sides by 17. That gives me 22 equals a sub 1 minus 13. Then adding 13 to both sides gets me a sub 1 equals 35. Okay, that's the first half of that problem. Now let's find d. Well, I know that since it's arithmetic that a sub n, so a sub 17, which is negative 13, should be equal to a sub 1, which we now know is 35, plus n, which is 17, n minus 1 times d. And we can solve that equation for d. So if I subtract 35 from both sides, it gives me negative 48. And of course 17 minus 1 is 16. D, and then dividing both sides by 16 gives me negative 3. And so that's the common difference. And there are my two answers. So you're probably noticing that we're using those formulas that I ask you to memorize quite extensively. So that's a thing that you need to get used to doing, is knowing those formulas and substituting into them correctly. Okay, so let's find the sum of each series. So problem A. The series starts at I equals 1 and goes to I equals 10. The formula that produces the terms is 4i plus 8. So after a little bit of practice, you'll start to realize that this one is definitely arithmetic, because the formula for the nth term is a linear formula. It's got I to the first. It's like 4i plus 8 is a linear thing. If it were y equals 4x plus 8, you know it's linear, right? So if it's linear, you know it's arithmetic. But in case you don't get that, what you might want to do is substitute in a few and see what the pattern is. So putting in 1, 4 plus 8 is 12. Then putting in 2, 4 times 2 is 8 plus 8 is 16. Then putting 3 in, 4 times 3, 12 plus 8 is 20. Plus dot dot dot. And then we'll put in 10. 4 times 10 is 40, plus 8 is 48. And if you look at the first few terms, it's pretty obvious that it's arithmetic, because we can identify a common difference. That common difference is 4. And of course the first term is 12. And so to get the sum of that series, S sub 10, we're going to use our formula. So that's going to be n, which is 10 over 2, multiplied by the first term, which is 12, plus the 10th term, which is 48. And that should be 300 when you do the arithmetic. So that's the sum of the first 10 terms of that series. Okay. So now let's move to the next example. B, and it's asking us for 9 times sigma k equals 3. This is different to 10. 4 minus 3k. Okay, so that's 9 times. If I substitute in 3, 3 minus 3 is 9, 4 minus 9 is negative 5, plus, then substitute in 4, which is the next number. 4 times 3 is 12, 4 minus 12 is negative 8, plus, put in 5, 3 minus 5 is 15, 4 minus 15 is negative 11, plus, dot, 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 and if I put in 10, 4 minus 3 times 10, 4 minus 30 is negative 26. Okay. Now, so here's where we've got to be really careful. We're treating this as a series, and I know that k started with 3, and it produced this. What we're going to have to do is figure out that this sequence in here, if we consider it as just a sequence and didn't know how we got it, then our first term would be negative 5. And our common difference would be negative 3. And we're going to have to figure out what n is. Because that series started with k equals 3, not k equals 1. So let's think about this a second. I'm going to let n be 1 to get the first term, 2 for the second, 3 for the third. And so how does that number relate to k? Because we got this first one when k was 3, the second one when k was 4, and then when k was 5. So the last one we got when k was 10. So what would n be? Well, the relationship between 3 and 1, and then 4 and 2, and 5 and 3, is that if you subtract 2 from the k value, that should be the n value, which means yes, that this is 8. Let me think a second. I want to make sure I got that right. So if we used k equals 1, no, yeah, that's right. Okay, so just making sure. So what we're going to find is 9 times the series as if k started with 3, which is the original problem, to 10. Did I copy that wrong? That may be what I'm mistaking this with. Oh, I copied the problem down wrong to begin with. Okay, so let me go back and fix something because I did mess up. I thought I had, but I couldn't figure out where that error was. So this is not 10. This should be 9. And so that wasn't 10 over here either. Okay, and this isn't going to be 10 here. So I apologize. I thought something was wrong. I just didn't see what it was. And it was basically I didn't copy down the problem correctly. Okay, this should be a 9 up here. Okay, and so this would be the last number we would have put in here. Oops, let me erase that. And there's something else I've got to fix because we got that 8 from a pattern that was wrong. So we need to rethink that. Okay, so let me get this back. So K3 gave us -5, K equals 4 gave us -8, etc. And it's K equals, oh, and that number's wrong too because I used 10. Oh my gosh. It's not supposed to be -26. It should be the answer we get when we put 9 in instead of 10. So 3 times 9 is 27. 4 minus 27 is -23. Let's see if that's right. Okay, so getting back to where we were, I apologize for the mistakes I just made. So when I got that last one, I got that from putting 9 in for K. And using the pattern we've established earlier, that means that N would be 7. Okay? So, getting back to where we were, this is from K equals 3 to 9 of 4 minus 3K. That's going to be 9 times. Now I'm going to use the information we gleaned above. That's going to be when N is 7. That'll give us this sum of these 7 things. Not 9 because that K doesn't work because it didn't start with 1. We have to start with 1 to use this formula. So when we start N with 1, the N value is 7 for the last one. And that's multiplied by the first one, which is -5, plus the 7th one, which is -23, and let me do that arithmetic really quickly. On my calculator. Let's see, did I do everything? I'm getting a different answer from what I did in my own notes. So let me just do that again. Okay, -882 is what I got. And that should be correct. I'm going to type something in my calculator to double check because, like I said, it's not agreeing with what I have in my notes, and I'm willing to say my notes are wrong. That can certainly happen, but I do want to check. So I'm typing this again in my calculator. Negative 882 is correct. Okay, I will fix my notes because they're wrong. All right, so anyway, that ends this lesson, and I'll see you in class. Again, I apologize for all of the mistakes I made on that last example. No excuse for it. All right, there we go.